Hi everyone! In today's tutorial, we'll be learning about filtering rows and columns in Python. In this tutorial, we'll be learning about label-based filtering as well as position-based filtering. And with the help of Python code, we will learn about filtering rows and columns on single condition, multiple condition as well as negated conditions. So, let's go! In Python, there are two ways of filtering the data. One is a label-based filtering method and second is a position-based filtering. Let's understand with the help of an example what is the difference. So let's take our data set where we have employee information, their department as well as their salaries. In label-based filtering, a data set is filtered using the row labels or column labels. So an example can be when we want information for employees belonging to marketing department. Then in label-based filtering, we will be very specific with the department column. We'll be writing the code like df.department equal to marketing. Similarly, if we want to retrieve a subset of columns, we will be providing the list of columns which we want. However, in position-based filtering, we don't provide some kind of filtering condition. Rather, we provide the indices of the rows or columns which we want. So example, if I want 0th, 1st and 3rd row, then I provide it as a list, that is square bracket 0, 1, 3, and then only those 3 rows will be returned. So that was the difference between label based versus position based filtering. Now let's move to our Python code. Let's start with firstly importing our library, and here is my code for my data frame. Now our data frame looks something like this. Here we have employee names, their department information and their corresponding salaries. Now we are going to start our Python code with label based filtering. So let's take an example. Suppose from this data frame we want to retrieve department column. Then there are two ways to do it. So number one way is either I can write df.department. Then it will give me the department column. And the second way is I can write df square bracket and within the quotes I can specify the column name. So I can write department here like this and then I'm closing the square bracket. So over here both of them give me the same result. However, my preferable approach is using the square brackets because sometimes when we are using some column names like employee name, here this is a single column name which is employee space name, but we have a space in between. So we cannot use this kind of method, because of which we use square brackets. So if I write df.employee space name, it will throw up the error. However, if I use the square bracket syntax, then it will not give me any error and it has returned me the correct result. Now the question is, instead of one column, what if we want to retrieve multiple columns? Then the answer is simple. Then using the square bracket syntax, we will write a list of columns which we need. So this was the normal square bracket. Now here I am providing my list. That is, suppose if I want employee name and salary column, then I will provide a list like this. So this is my list over here and here I am using the square bracket syntax. If I run this code, see, it has given me my result. Similarly, we can also filter the rows based on a condition. So let's have a look at our df again. Currently from our df, if I want to retrieve the rows of employees belonging to marketing department, I can write my code simply like df square bracket, and now here I want the employees from marketing department. So to retrieve the department column, I'll write something like df square bracket department, and then I'll write double equal to, and within quotes I'll write marketing. So what does it do? It firstly searches for department column, and wherever it's the marketing department, it will assign the value true corresponding to it, and then it will give me the result. So over here see, and notice when I'm comparing the things, I'm using a double equal to sign and not a single equal to. Now let's discuss about .loc method. .loc method is a very popular one in label-based filtering. So for this, the syntax follows something like df.loc, that is, here is my data frame name .loc and then square bracket a comma b. Now instead of a, I provide my condition on rows. So let's say in this example, my condition on rows was df department is marketing. So this was my condition. And after this comma, there is B. Instead of B, what we will write is the list of columns which need to be selected. So let's take an example. Suppose if I want the information for marketing department, but I only want two columns, which is employee name and salary. I will write the code something like df.loc, which is my data frame name. Here is my condition, which is A. Now I'll write a comma. And now I'll write my B, which is nothing but a list of columns which I eventually want, which is employee name and salary. So this is my final result. Similarly, using .loc, we can also retrieve all the columns. So here I will write my code as df.loc, and suppose I want all the columns for marketing department. Then after the comma, I have to write something like a colon symbol. So this indicates that get all the rows from marketing department, but I want all the columns. If I don't enter this colon, then it will give me an error. So let's run this code and see, it is now returning all the columns. Similarly, let's say if I want only two columns, which is employee name and salary, but I want all the rows for it. So instead of this condition, I'll write the colon symbol over here. So this code indicates that from the df, get all the rows, because here colon is in the position of A, which means condition on rows. And here we are specifying colon, which means get all the rows. And in the position of B, we are specifying the list of columns. So get only these two columns. And if we run this code, we have got our entire df, but with only two columns. Let's discuss about filtering for multiple conditions. Let's have a look at our df. Now, in this df, we have got different departments and salary information for employees. Now, suppose our criteria is that we want the list of employees from marketing department who have a salary of more than 45,000. Then there are two criteria in this. That is, number one, we want a filter on marketing department, that is department equal to marketing. And secondly, we want another filter, which is salary should be more than 45,000. So let's see how do we write this thing. For this, we have got two conditions. So I'll write df.loc square bracket. Let's assume we want all the columns. So that's why I'm writing comma colon. And before this comma, what are my conditions? My first condition is, that is, it should be department is marketing. So within the parentheses, I will write df square bracket department, and it should be double equal to, and it's marketing. That's my first condition. Let's firstly run our code till here. Oops, I need a double quote over here, my bad. So see, we can see that it's a marketing department. But my second condition is that I want the salary to be more than 45,000. So what I will do, I will write this and then I will write within the parentheses, I will write my second condition, which is df square bracket salary, and I will write more than 45,000. So over here, I want both the conditions to be true. That's why I'm using the and symbol. And both the criterias are written inside parentheses. So let me run this thing. So there was only one employee from marketing department who had a salary of more than 45,000. That's why we are getting this only one single row. Now, what if we want either or condition? That is, any one of this condition is true, then I want the result. So for this, if I want either the employee should be from marketing department or they should have a salary of more than 45,000, then instead of this and symbol, I will use this vertical slash. A vertical slash in Python means or, that is, at least one of the conditions should be true. So as a result, we can see that over here, this person is from HR department, but they have a salary of more than 45 grand. That's why their row is present. Similarly, although the salary of this person is less than 45,000, but since this person is from marketing department, that's why this is present. Now, if we have a look at our DF, then we see that there are three departments, which is sales, HR and marketing. Suppose if I want employees from sales and marketing department, I can write the code something like department is sales, department is marketing, and I can copy paste it something like department is sales. So either the department should be sales or marketing. That's how I can write, and it will give me the correct result. However, there is a shorter way of writing this thing, Because let's say if I wanted employees from 5 different departments and I'm using the same column department, I will not be writing department equal to sales or department equal to marketing or department equal to A 7 times. Rather, I can use the .isin function. So how do I write it is df.log square bracket, and let's say I want all the columns. So I'm writing comma colon. Now in this thing I will write df.department .isin, and now within this isin I will provide my list of values which I want. So over here I can write sales and then marketing, and I'll close my list here. So it's looking for the department column where the values are in this list. So if I run this code, it is giving me the exactly same result as above. Now what if we want to negate the condition? Suppose we want the rows where this condition is not at all satisfied. So then the not equal to operator in Python is nothing but this tilde symbol. So before my condition, if I'm writing this tilde symbol over here, then it means give me the results where this criteria is false. That is, wherever the department is sales or marketing, do not return me those rows. Then with the tilde symbol, we can do this thing. So if we run this code, we can see only the row for HR department is available to us. In label-based filtering, there is another method which is called pd.query. So let's see how it works. So when I'm filtering my data set using .log function, I was already specifying my column names again and again, like df.department, df.sales, right? But then in .query, I can get rid of it. So over here, I can write something like df.query, and now within the quotes, I will write my condition. So if I want salary is more than 45,000, that's it. Notice here, I am writing my condition in quotes. Secondly, over here, I'm not writing df square bracket salary, because query function helps us in getting rid of that df square bracket. So I don't need to mention the name of my data frame again and again. Now if I run this code, this is giving me the accurate result where salary is more than 45,000. Let's take another example where department is marketing. So if I write something like df.query, and if within the quotes, if I write my condition department double equal to, and now it's, since marketing is a text variable, so I'm writing it marketing in double quotes. And now if I run this thing, here is my result. Let's discuss about position-based filtering. Position-based filtering has a very similar syntax to .log, where in position-based filtering, we are using something called .iloc. And instead of the conditions or column names, we are going to provide the positions which we want to retrieve. Let's again have a look at our df, and suppose from this df I only want 0th, first and second row. So I can write something like df.iloc. Now in this iloc, the syntax is again something like a comma b, where a means the position of the indices which I want for rows, comma b, where b is the column numbers which I want. So let's assume I want all the columns, so I'm writing comma colon, and I want only first 3 rows. So I can write something like range 3. So here it has given me first 3 rows. Similarly, instead of first 3 rows, if I wanted 0th, first and third row, then I can give the list of numbers. So I can write 0, 1, 3, and it's giving me the required result. Similarly, suppose if I want all the rows but only specified set of columns, so I can enter their position number. So let's say I want df.iloc. Since I want all the rows, I am writing colon, comma. Now instead of b, I will be writing the list of columns. Suppose if I want this employee name and salary, then I will write 0 and then 2 as a list. So list 0, 2. And then square bracket close. So over here, this is my list of column indices. So see, here is our result. Similarly, we can combine the functions, that is df.iloc. I can write range 3. It will give me the first 3 rows. And if I provide this list, then it will give me only for 0th and second column. Now there is a special function in NumPy library which gives us the indices when we provide a specific condition. So firstly, let me import my NumPy. So I will write import NumPy as np, and let me have a look at our df. So let's say I want the indices where department is marketing. So I can write the code using where function from NumPy. So I'll write np.where, and in the brackets I can write df.department equal to marketing. When I provide this thing, see, it has returned a tuple where it's returning me the arrays. So that is in position number 3, 4 and 5, my department is marketing. And I can use this in my .iloc function. So I can write df.iloc and I can write this entire condition with a square bracket 0 and then colon. Suppose I want all the columns. Then if I'll get the rows for marketing department using iloc. So that was all about filtering rows and columns in Python. Do let us know in the comments below how did you find this video. Until then, see you soon.